Okey-doke. Okay, so it is time. Hi, my name is Oleg. We're gonna learn today about my vision, how people can build different agentic applications and AI workflows, and some of the ideas that we should treat those more as applications and maybe less of a YOLO the situation together and yeet it into production to make somebody else's problem a few months down the line. So in my experience, and my background is application development, so I know developers, and they are a little bit different professionals than machine learning and AI experts. So let's do it quick. Who is more of a developer rather than an AI person here? Okay, most of you. Very, very good. How many of you are actual AI people? Can I? Okay, so no sensitive jokes. Very good. Just kidding. Just kidding. So, as an application developer, and my application development friends and people who I talk to, when you build AI agents, it probably starts like this. So you have this glorious idea that there is a task that you would like to automate or completely defer for the AI overloads to solve for you. And you open your favorite AI assistant software. It could be Claude Desktop, it could be your Goose AI assistant, it could be your, I don't know, VS Code with the AI integration enabled, or anything else. Or it could be your favorite AI agentic framework creation, I don't know, ADK, LangChain, anything like that. And then you start writing some prompts, because at the core of the AI agent is still that artificial intelligence should be smart enough to do something for you that you actually want it to do. So you start writing some prompts, and you start trying to convince this machine to solve and think for you. Which, if you think about this, it's a wonderful technological process. Like, we are not impressed by AI, but if you think about that, it's carefully crafted pyramids of sand of a minuscule size, put on a plate, on a silicon plate, and we hit them with electricity. And when you hit them in the right way, you can force them to think for you, which is magnificent. It shouldn't work. It's kind of sort of, when you say it like that, like you understand that it shouldn't actually work. Like, it's ridiculous, but it does. So you craft some prompts, you just explain your problem to your agent, to your AI, and then it sort of starts giving you the responses where you believe that it can actually take this task on itself, right? Maybe you want to convince it to create social messaging for you by watching YouTube videos. Or maybe you want it to be your financial advisor, and you read the news and tell me if NVIDIA will crash after the announcing the revenue and the profits for the quarter, right? Or anything else. And then the responses come back and they sort of make sense. And you're like, okay, so the next thing I want for this to be an agent or a workflow, I need to actually give it tools to affect change in the world. So you connect some tools, and you can write them by hand as functions in your favorite agentic framework, or you can use something like MCP, Model Context Protocol, to have the servers that connect and give your LLM, your AI, ability to actually affect change in the world. And you're like, okay, this is great. And then you connect the tools, and they sort of work, and you fiddle with configuration, and you're like, my tools need access to systems. I want my AI agent to go to GitHub and download stuff and get access to repositories, or close tickets in Jira will want to implement, or answer that annoying product people on Slack when they ask you for things. You're like, you don't want personally to respond. We're going to consider this putting on the backlog. No, you want the AI to do that for you. So you need to connect things. For that, you need tools. And you whip up some tools, and then you have this GitHub repository with maybe prompts and the tools configuration on your machine, and then it just sits there, and at best, you're going to put it on GitHub, right? And this is where a lot of agentic workflows kind of go to not die, but to live forever in a state of limbo where they're not useful to anyone, and even for you, because after a while you will forget how to use that particular thing and it just goes away. So that's not the way. What is much, much better is if you would consider agentic workflows or AI agents, applications, and treat them as such. And for that, you need to decompose that larger task into subcomponents that you can solve in a repeatable and isolated manner. So any AI agent needs three things, right? It needs the model to be the brain of the situation. It needs the tools to have access to the third-party systems to affect change. And then it needs some business logic, which you can provide as code or as system prompts or the user queries, right? It needs some configuration to be distinguishable from the general purpose ChatGPT that people can go and just ask as the ChatGPT. You want a specific solver for a specific problem. So you need those three things. And they are actually individual components that you can put together. And if you think of that, your agentic application is exactly those. You have the service that you're going to interact with, either manually via the chatbot interface or be an asynchronous AI agent that reacts to some events. Maybe it's subscribed to your Kafka, or maybe it listens to, runs on the cron and checks your emails. But there's an agent application that reacts to the inputs and will provide you with outputs. It's going to use the AI, the large language model, in the current kind of sort of spiral of the hype, as an external service. It's going to, in the application world, the AI is reduced to being a third-party API call. Whether you host your models locally or whether you depend on the managed models provided by someone, this is it's an API call. And then you have the tools which will be in our universe. Hopefully, we're going to standardize on something like MCP. Those will be standalone applications that have the API that your agentic application knows how to call, and they have their configuration to access third-party systems. And those are separate, and they can be configured separately. And this is exactly what I would like to talk about how you can solve. I'm from Docker, so I'm going to talk about Docker initiatives in this space, which you don't have to actually use, but it would be very cool if you know that they exist. And one of them is the Docker Model Runner, which is the ability of the Docker desktop or Docker CE environment to run LLMs locally on your machine, wherever your Docker environment is running. The LLMs are packaged, so we don't actually invent the inference engine ourselves, of course. We package, currently it's a wrapper over Llama CPP, but it's packaged within your Docker primitives, and you can install them, and you can run and serve the models with the same ease as you run containers for all other software that you wish to run. The models are stored as OCI artifacts on Hub or any your internal OCI registry, so you can push them there. You can pull models from Hugging Face, and in general, this is very, very easy, and it's nice. So you can say Docker model list, and you have a bunch of models. Come on, Docker, you're embarrassing me. What is happening? Oh no, wait. No. We are two. Docker model list, and you see the list of models that we currently have in our context available. So we can do Docker model run, say the model name, we get the chat, hello, and you get the chat experience. It also provides you with OpenAI endpoint, OpenAI API compatible endpoint, so you can actually wire your applications to talk to this. And so this is nice and clean, and it's the same experience as with running containers. If you have an LLM that you want to run, and currently local LLMs are not at the state of the managed models that you experience when you go to Claude or when you go to OpenAI, but they're very, very capable. Currently, local models that you can run on your local hardware are approximately 2 years back state of the art what we had online. Right? So 2 years back, it was, I think, currently a 4 billion parameter model that can run a Qwen 4 billion parameters is very comparable to ChatGPT 3.5, which was 25-ish months ago, right? And if you remember yourself 25 months ago, you were like, this is amazing. I'm going to change the world with access to this technology. And now we can run this locally. So now it's not impressive at all. But you can run models. So that is one part of our diagram here, right? Is large language models can be run locally or served internally. And they are separated from everything else, right? You can fully control how you want to run this, what models you run, what quantization you run at, how much you want to configure memory, context sizes, and so on. You can have your private assistants run privately with the same experience that you already have in master. The second part was tools. So you need the catalog of tools. You need to figure out which servers and which external systems you can access very easily. Docker has the MCP catalog and MCP toolkit, which is a piece of software where your Docker environment becomes, or a Docker image. There's an image, so you can run this in the container form as well. It becomes an MCP server that can run other MCP servers and present a cumulative list of the tools, prompts, and resources from those. So in your local environment, you can go to the toolkit, you can find the catalog, and you can enable the MCP servers with all their tools just by clicking a couple of buttons. And then you can, for example, configure particular clients with just a few buttons. And then in there, you will have access to those tools. The configuration is centralized in this MCP toolkit. It will handle the isolation of the servers for you with the sandboxing within containers, which is friends.lend friends run random npx processes on their host machine. We already kind of sort of overgrew the infamous curl to sudo installation methods, and we shouldn't run other people's software without any kind of sort of sandbox around it. And if you are in security, you're going to be like, oh, like containers are not actually secure. And that would be like, yes, they're not. But they're still better than running code as root on your machine with all the access to things, right? And configuration. You have multiple MCP servers, right? How do you configure them? You put your API keys into your environment, right? And then everyone has access to everything. So my YouTube transcripts MCP server, if I run it as just npx processes, will have access to my Jira credentials and will go and, like, I don't know, offend my colleagues on Slack. I don't want that. So you want to have certain level of isolation. MCP toolkit is wonderful because it provides the secret configuration. You can map things. It isolates things separately. It handles the life cycle for you. And it's available with this click ops kind of sort of way. But also there is a Docker image that you can configure. So you can write actually the container and wire the container that will do this for you. So those are the tools. And then you need the system prompt, so the business logic. And there, of course, no one can help you. You, as a developer, you have to actually invent whatever your agent does by yourself. But you can encapsulate everything else. And I want to show you a bunch of examples. And one of those examples is, of course, one of the favorite AI assistants that I have is Goose by Block. It's open source. It's an assistant, and it also runs as the command line application, which is very, very nice. So here is an example of me doing a little agentic workflow. Is I would build my Docker file, which will be my agentic application. I will install Goose by using the normal installation procedure. I will configure Goose using the files to talk to my primitives. I will use the Docker model runner internal endpoints to make my AI, actually the brains available. I will configure model in my compose file, but I will configure Goose to connect to my Docker model runner, and will configure Goose to connect to the MCP gateway on the path that I will also provide internally. So now the compose is the magic that happens to do the orchestration of this. It's wonderful, right? If we have separate components, we can put them in a single YAML file that you already know how to use, because you are using this for your whole application development needs, right? So I can put my AI agent in it. I can make it depend on the gateway. I can specify my MCP gateway to be that particular server. I want to run the YouTube transcript, MCP on top of that. Compose has the high-level, top-level primitive for models, which is a recent development, but you can actually specify which models you want to expose from your Docker environment. I'm going to use this Onslaught Qwen3 mixture of experts, 3 billion active parameter model, which is recent and good in my experience for small tasks. I can configure the context size for that if I want. And now, all I need to do to run this combination of things, to run my Goose, to run my model, and to run my MCP servers, is to do Docker compose up. You can build the things if you want. It will start, and then it will tell me that, okay, it's running, everything is running, and I can go to the port where this is all exposed. I'm using a utility called ttyd, which is the terminal in the browser. Even if you don't learn anything about running models or Docker technology here, terminal in the browser makes your demos pop. People love it. Right? So it's a command line application Goose, but it's in my browser here. And I can do various things. I can say hello. It will go and wire to my local LLM running. Like you can see my GPU spiking. And then it responds. And remember, we said that it has access to the YouTube transcript server. So what I can do, actually, I can be like, okay, let me give the URL here by this aspiring YouTuber. Smash that subscribe button while you're at it. And we can say, like, what's this video about? And we say answer in 5 sentences. So now what will happen is my application, this agentic Goose thing, my agent, will figure out what I want, will go and look at the tools that are provided by another container, and it will answer me with some information that it pulled from YouTube. Now, the beauty of this approach is that all I need to have for that is this compose file. I can send this compose file to anyone. I can publish it as an OCI artifact, and then to run this agent, right, which is complete. Well, so there is no actual system prompt or specific logic to make it better than anything else at recognizing YouTube videos. But I can put my system prompts in there as well, right? I can configure this. It doesn't have to be Goose. It could be your favorite ADK Python application with prompts and configuration, or it could be CrewAI agent configuration. The point is, I will package it and run it as a container. I will build it, make it a building block within my larger compose file, and then I can then share with myself or other people to run this. Because I can already do that with containers, because we do that with applications all the times. Here, wait. So I have this another little compose file that defines a service called Cloudflare. Cloudflare D, and I'm tunneling public cloud to my Honey container. Honey is actually Goose in Estonian. Today you learned 2 things. ttyd, terminal in the browser, and Honey. Learn something. I'm from Estonia, so that's why I know. If I run both compose files, I will also include this Cloudflare service. Right? Because now it's just an application. Now it's not my AI that is crazy and wonderful and can do magical things. But it's just an application. So here, I have this URL that Cloudflare does. And I'm going to go and I'm going to say QR code generator. And we're going to go to the first one that is not sponsored. We're going to accept everything. We're going to put it here. We're going to generate. Now, here's the QR code. Somebody with a phone. Open the URL. Not all at once. My machine is not that powerful. But somebody, it should open you the Goose command line terminal. And now you can use that. So this is the most primitive deployment way for your agents running locally. It's just making them available on the internet because it's just an application. So make my GPU spike. So somebody got to it. Thank you. Stop it. Give me my machine back. Give me my machine back. Right. Oh, by the way, so here in my Docker models, what I can also do, because this is my backend, I can see the requests and responses for everything that happened in there. So all the nasty things that you put in, I'm watching you. They will be reported to Santa Claus. No, so now it's just an application, and now it's configured by the compose file, right? What is great about this is that for my agent, I have this unified standard way of deploying it. You probably don't deploy compose to production, but it works with the same primitives that you do actually deploy, which is containers. And if you want a system of agents, this is a much, much better way to build individual agents with their individual configuration, with their individual tool access that encapsulated in a system that actually works and does one small thing well. And then building system of agents by providing multiple agents together in this individual primitives. And then you can deploy those, and you don't even need to deploy them maybe manually through the things, right? So we have our MCP gateway that was the tools and secrets and everything. We can encode our agent to run everything in containers, so it actually makes it repeatable, reproducible, and shareable. And then we have this thing called Compose for Agents, which is the way to use Compose with a bunch of examples to run them as individual agents. And then you build system of agents by providing individual components like this. And if you go to GitHub to the system of agents, Compose for Agents, you can see there are a bunch of examples, and we are not going to go through all of them right now, but you go to any of those examples. So for example, A to A, right? And there is an example how to build systems with A to A. And what you do, what I want to show is that when you want to run this system of agents, you do Docker compose up. And your compose file will be the same all the time. There will be the actual agent configuration. There will be your tooling configuration. There will be your secrets and models if you need them locally. And then if you go to another version of this, for example, Crew AI, you're going to see in the README that what you need to do is compose up. And then the system is there. It's exactly the same. There will be your agents, there will be your MCP gateway, and there will be your models. Because to build an agent, you need those three things glued together. And the hard part is to actually understand what problem you want to solve, and then make the system repeatable enough that you can evaluate it, and then share that agent with the world. Right? That is the hard problem, and it's much, much easier if you rely on the actual components that we know work and that already are within the developer tool belt. So here you can have those things. You can run them as individual compose files. And it's not just that, right? So recently, this approach has been picked up by other players in the ecosystem. So Google recently announced, for example, they have the Google Cloud Run service on Google Cloud Platform, right? And that is the service to run containers, a serverless solution for containers. And they were like, oh, this is actually wonderful. They recently announced the GPU support, so you can get containers with GPU access if you want to host models locally. But they also announced access that you can run your compose files directly in Cloud Run. We're working on enabling this with Azure as well and other cloud providers. So this is new. This is an interesting application developer approach to writing AI agents. But it makes them repeatable, and it makes them actually building blocks in the much, much larger ecosystem that exists. And then the world is your oyster. Just go build whatever you want and share them with friends and make them use it. And hopefully it's going to be much, much easier than gluing together things and throwing them in GitHub repo and making extensive readmes how to run stuff. Thank you so much.